Many types of electronic equipment are required by the military services for communications and for other purposes. These devices are so varied in design, so complex, and so important that they must be maintained only by qualified technicians. Well-trained workers are doing a good job of keeping the equipment in first-class condition. However, both the newly qualified man and the experienced technician may expose themselves to hazards which may result in severe and even fatal injury if they do not cultivate safe working habits. The purpose of this film is to point out the hazards and to show the working habits which will keep the electronics workers safe. First of all, check yourself. Don't wear jewelry or other articles which might catch on the equipment or conduct electricity. If you're required to wear a metal identification badge, make it safe by covering it with an insulating shield. A prime rule of safety is to de-energize equipment before working on it, whenever the job permits. Cut the switch on the equipment and pull the plug. These are only the first steps. You must make sure that the equipment is completely de-energized. The large capacitors, which you can locate in the diagram of the equipment, may still be a source of danger. Even if the device is equipped with bleeders to drain off the stored-up charges, safety demands that all of the large capacitors be located and discharged. There's a risk that some of the capacitors may be overlooked due to their resemblance to other components. 3 of these are capacitors. These 2 are not. It's even harder to tell them apart when they're partially concealed in the chassis. But there can be no mistake when they are located one by one in the diagram and then discharged. Use a grounding bar designed especially for this purpose. Always familiarize yourself with the equipment by studying the instruction book. When all the large capacitors have been discharged, the circuits should be dead. But a safe worker takes nothing for granted. Always test for the presence of unexpected voltage using a meter known to be functioning. Again, you need the diagram. The meter reads 0. The equipment is dead. It is now safe to proceed with whatever work is required, such as troubleshooting. The resistance checking method is recommended. It's effective and safe. We have shown the safe procedure for de-energizing equipment which is merely plugged into the electric power source. But where equipment is permanently wired in, additional precautions must be taken. Be sure to turn off the switches on the panel. And don't forget any switches that might cause the equipment to be controlled from some remote location. Then open the main supply switch and always be sure to tag it. The tag is for your protection. Write your name on the back. The safety rule here is that no one else should touch this switch while it is tagged, and only you should remove the tag when the job is finished. Do the same with every circuit through which power can reach the equipment. Strip heaters, for instance, may be powered from a separate line. Be sure that they are not forgotten. Remember, always de-energize equipment if the nature of the work permits, and be sure that it's completely de-energized. The life you save may be your own. Frequently, it is necessary to energize equipment when making repairs or adjustments. Always get permission from the person in charge before starting. Identify all live equipment with warning signs. And bear in mind that no voltages encountered in service equipment are so low that they don't have to be handled with care. Never work alone on live equipment. No safety regulation is more important. It's very important, too, to practice good housekeeping. There should be ample working room, good light, and no litter. The floor should be clean, dry, and preferably made of good insulating material. It's always safest to stand on a special insulator, such as a rubber mat. Before you start to work, find out exactly how this equipment differs from other types on which you've worked. It pays to look before you leap. Use the proper tools and be sure that they're in a safe condition. Screwdrivers with plastic handles are safest. Avoid the dangerous type with a metal shaft projecting through a wooden handle. Your test equipment should be checked periodically. Examine your test leads carefully and frequently. The slightest break in the insulation makes them extremely dangerous. Wear rubber gloves and look them over thoroughly before putting them on. If you find holes or cuts, get new ones. Now you're ready to go to work on energized equipment. With hands thoroughly protected, feet well insulated from the floor, tools in good condition, a clear idea of what's what in this particular device, and proper working habits, you don't need a four-leaf clover or a rabbit's foot to be safe on the job. Sometimes it's necessary to use the bare hands to get into really tight spaces. Here's the proper routine. Make a habit of this procedure and you won't get hurt. First, de-energize the equipment. Cut off the power. Then, discharge the capacitors and touch the grounding bar to the terminals which are to be used in the test. Now, it is safe to clip the meter leads to the terminals. Check again on what you are doing and then re-energize the equipment. Now, without touching the meter, read the voltage. Once again, turn off the power. Momentarily ground the clips before touching them. Now it is safe to move the meter leads to other terminals. Go through this entire routine every time you move the clips to new positions. Working with bare hands on energized equipment is extremely hazardous. If a circuit is established from hand to hand, the current travels through the heart region, and under certain conditions, even low voltage may paralyze and permanently damage the muscles which control blood circulation and breathing. When you work with only one bare hand, contact with a live point will set up a circuit only in the hand or forearm, provided that no other part of the body is grounded. Therefore, the possibility of serious injury is very greatly reduced. If you receive a minor shock, resist the impulse to thrash around. This might result in contacting a more dangerous live point. And again, let's emphasize that a man should never work on energized equipment without somebody else close by. In case of shock, the other man should take these steps. First, cut the power immediately. Second, start artificial respiration. And third, summon aid while continuing respiration. The shorter the duration of the shock and the quicker the first aid, the better the chances of the victim for survival. Aboard ship, electrical hazards are increased by the presence of steel bulkheads, decks, and fittings, as well as by cramped working spaces. Moreover, surfaces may be damp, and the technicians themselves may be hot and sticky. It is vitally important to insulate every metal surface close to the equipment from contact with the technician's body. Unless these precautions are taken, there's a great risk of establishing a circuit from hand to foot or from a hand to other parts of the body. It is essential to have an alert co-worker who knows what to do in case of a shock. And to prevent shock, the wearing of rubber gloves is absolutely essential. The free hand as well as the working hand must be protected, as it may come in contact with metal surfaces. If the ship is at sea, the free hand may be needed for support. The other man, too, must wear rubber gloves for full protection. With bare hands, all his first aid training would be of no help to the technician in an emergency. While the technician works, the other man should be ready to cut the power instantly in case of shock. In a situation like this, frequent reference to the circuit diagram is especially important. When the skin is sweaty, as it is apt to be here, its resistance to the flow of electric current is lowered, as we can see in this simple test. When the skin is dry, it offers a comparatively high resistance to the passage of current. But when the skin has been moistened with salt water, its resistance is greatly lowered, and a given voltage will cause a much higher current to flow. So, if this man were not wearing rubber gloves and taking all other precautions as well, ordinary direct or alternating current, or the highly dangerous radio frequency current might burn through his sweaty skin and travel readily through the salty body fluid. Think ahead. Anticipate every hazard, and you will avoid establishing a circuit through the body even when working under especially hazardous conditions. In the doors and panels of some equipment, interlocks are installed as safety devices. When the door or panel is opened, the interlock automatically breaks the power circuit. When the equipment must be worked on while live, a special clip, and only a special clip, should be plugged into the interlock to keep the circuit energized. This special clip is so designed that the door will not close until it is removed. The man who uses a bit of solder or other makeshift instead of the special clip, so that the door will close without removing it, is setting a trap for the next man who opens the door, for he may assume that the interlock has cut the power. Don't be guilty of such a crime against your fellow workers, or perhaps even against yourself. The electronics technician must take precautions against mechanical as well as electrical hazards. The replacing of cathode ray tubes offers a good example. First, the equipment must be de-energized as we have described. Then the tube must be allowed to cool before it is removed in order to prevent burns. Face, body, and hands must be protected against the hazards of implosion of the tube. Flying glass can cause serious injury, and the fluorescent coating is poisonous. The tube must be handled with great care. Examine the entire surface of the tube. A cracked tube is unsafe. Never lay down the tube where it might roll or be scratched. Replace it in the special carton. Handle and dispose of all tubes in strict accord with regulations. This is particularly important in the case of fluorescent and radioactive tubes. If broken, they can poison the careless handler and any nearby personnel. In working on electronic equipment, you can't be too careful about what's underfoot. Don't let tools get scattered about on the floor. A slip or a fall, not dangerous in itself, may be the cause of a very serious shock. Always be on the alert for the mechanical hazard which is so often present in electrical work. Determining the presence of voltage by hand is always a dangerous procedure. Voltage which is harmless under certain conditions may be quite the opposite in different circumstances. For instance, when the skin is damp. Moreover, high voltage may appear at points where only low voltage is normally encountered. Always measure voltage with a meter. Intentionally taking a shock is strictly forbidden. Skylarking is another extremely risky practice. Usually, the fellow who plays practical jokes doesn't bother to figure out all the possible consequences. Just a little fun, but if the victim jumps up and gets his hands into high voltage area, the result could be very serious. Don't endanger someone's life just for a laugh. Skylarking is out of bounds for the safe worker. In summary, safety begins with the elimination of all possible hazards. Safe working conditions include ample room, light, order, and cleanliness. Make sure that tools and equipment are in a safe condition. Always familiarize yourself with the device before working on it. If the job permits, de-energize equipment completely before starting to work. Identify all live equipment with danger signs. Take all necessary steps to avoid establishing a circuit through the body. Use special precautions when working conditions are especially hazardous. Make a habit of working with only one hand and with someone else close by. Keep posted on safety by studying the service manuals, bulletins, and electronics periodicals. In all situations, you can be safe through the cultivation of proper working habits.